I'm Stuart Lane. I'm Professor of Geomorphology at the University of Lausanne in Switzerland, and a major part of my research activity involves the use of numerical models. Yeah, normally when I want to do some mathematical modelling, I'm motivated by a question. So I will look at the question. I will think about what kind of modelling strategy, what kind of data needs, what data I can't collect, because that will then limit the model that I can choose to use, what opportunities there are for innovate with the modelling. And that, of course, is ultimately driven by a combination of the question and the disciplinary network within which I sit, which is a little bit uncomfortably situated between hydraulics, hydrology and geomorphology, and each of those communities have different ways of modelling, and my job is to find a way forward that fits within their network. When we did the projects in Uckfield and Pickering, where we developed the models with the community, my network, the group of people within whom I developed my model, changed. And so rather than me going and telling the community what the question was that I wanted to model, with the community members we developed a basic understanding of what the system was and what the things were that we thought were important that needed to be included in our model. So we went about it a very different way. Now what that immediately meant is that the model that I'd wanted to use I could no longer use, because it didn't do what we had discussed we needed the model to do. So with my colleague at the time, Nicodoni, we had to write a new model from scratch, which would deliver what it was that we were trying to achieve as a community academic collaboration. The other difference then was, although I think it's fair to say the actual programming of the model, which Nicodoni did, and that was done very much out of these meetings, because that's a very technical activity, but the model was then developed along with the community. So we used the model with the community, and they would look at the model and say, hang on a minute, that model doesn't work like that, that's wrong, you need to change that. Or if the model can do X, can't you make it also do Y? Because Y, we think, would also be very interesting. So the trajectory of model development was then largely driven by these series of regular meetings where we used the model together, and we used that model usage to help us work out what the model was doing well, what it wasn't doing well, what it could do, and then in turn develop the model further. Without a doubt, the Pickering-Uckfield way of modelling was by far the most challenging I've ever done, and I think without a doubt the most rewarding. I think we produced much more innovative modelling solutions in having to work that way. We came up with different ways of thinking about what needed to go in the model, different ways of making model assumptions, different ways of validating the model. It was a very, very different way of working, and much, much more interesting than sitting in my office day in, day out trying to make a model work. My advice would be to turn on its head some of the basic strictures that we tend to impose upon ourselves as scientists. Following all of the rhetoric around traditional scientific method, that you've got to keep yourself separated from what you're researching, you've got to try and be completely independent of what it is you're researching. Immerse yourself in the research problem, in the research question, and see what that can do to you and your capacity to be creative and innovative, to break off those networks that you think limit what you can do, those disciplines that limit what you can do, and embrace the creativity that can come from having to work with a different kind of community. To do that, you have to get over this fundamental and extremely naive assumption that the only science that is good science is that which follows traditional scientific method.